Hi, I'm Tom Nahumi from DELL EMC. In this second part of the demonstration, I'm going to show you how to run application-consistent backup and restore of Red Hat OpenShift Kubernetes workloads using DELL EMC PowerProtect. PowerProtect Data Manager supports agentless application-consistent backups of database applications that reside in Kubernetes pods. This existing infrastructure handles database backups, so no pod compute resources are required. With the new version of PowerProtect, version 19.5, customers can run application-consistent backup and restore of MySQL and MongoDB containers. Additional applications will be added in future releases. For the purpose of this demo, I installed OpenShift 4.4 cluster, which is based on Kubernetes 1.17. I deployed an instance of MySQL database, and as you can see by navigating to the PVCs tab, that this pod has a 20 gig persistent volume, which is bound to it. In our case, this persistent volume is a PowerStore volume which has been created and mapped using the PowerStore CSI driver. If I go to the PowerStore and navigate to the Volumes tab, we can see that this OpenShift persistent volume is basically a PowerStore volume which is mapped to one of the worker nodes and mounted on the pod. In order to use the application consistency capability, first of all, we need to import the ppdm-ctl utility from PowerProtect to our workstation where we run the kubectl commands from. Then, we need to deploy the application templates. Application templates translate the specific configuration details and required interface steps for each database application deployment to the standard PowerProtect Data Manager backup functionality for Kubernetes. The application template defines actions that PowerProtect Data Manager automatically performs on discovered resources, including ways to order the actions into a sequence. Now, let's navigate to the PowerProtect UI. Under Asset Sources, we click on the Kubernetes tab. We can see that our OpenShift cluster is already registered to PowerProtect. During the registration, a PowerProtect pod is deployed in order to communicate between the OpenShift cluster and the CSI driver. Next, I'm navigating to the Protection tab and selecting a protection policy. I'm clicking on the MySQL policy that I created in advance. We can see that the 20 gig persistent volume is configured for backup. Now, it's time to run the backup job. I'm navigating to the Assets tab and searching for my namespace. Then, I'm selecting it and clicking Backup Now. I can go to the job to monitor the progress of this backup, and as you can see, this job is already running. Application-consistent backups occur when the database application is informed of a pending backup. The database completes all pending transactions and operations while typically queuing new requests. This process places the database in a sequence state of relative inactivity where the backup represents a true snapshot of the application. This backup now captures items that would have otherwise been stored only in memory. After the snapshot, the application resumes normal functionality. In most environments, the snapshot operation is instantaneous, so downtime is minimal. I'm running the kubectl get-snapshots command, and as you can see, this snapshot has been created and it's ready to use. By going to the PowerStore UI and selecting the persistent volume, you can see that this Kubernetes snapshot is actually a snapshot of the volume at the storage array level. This snapshot is a PowerStore volume copy, which means that it is globally data reduced, metadata based, so the creation, restore, and deletion is instantaneous, and this is not a copy on write copy, so there is no performance impact. At this point, I will fast forward the video up to the point when the backup task completed successfully. Now, let's run the application consistent restore of our MySQL pod, including the persistent volume. From the main page, I'm clicking on the Recovery tab and selecting Assets. I can see my MySQL namespace here, and by clicking on View Copies, we can see that all these restore points are application consistent. I'm selecting the latest one and clicking Restore. Here, I have an option to restore it to an alternate Kubernetes cluster or to my original cluster. I'm selecting the original cluster and clicking Next. Then, I can choose to restore the whole namespace or just PVCs. I'm selecting the whole namespace and clicking Next. Then, I can choose between the original namespace, a new namespace, or an alternate namespace. I'm selecting the second option and providing a name for the new namespace. Then, I'm selecting the PVC I want to restore and click Restore to start the task. Within a few seconds, the restore status is changing to running. I can see that a new namespace is created and the pod is being restored from backup. At this point, the PowerProtect pod is restoring the persistent volume data directly from data domain. If I navigate to the PowerStore UI, I can see that a new volume has been restored from data domain directly to our PowerStore cluster. By navigating back to OpenShift and selecting our new namespace, we can see that the restored pod is up and running, connected to the restored persistent volume. I hope you will find this demo useful and thank you very much for watching.